Hello, everyone, and welcome to today's panel discussion. My name is Aaliyah Pollock, and I work as an AI data and technology analyst at the Royal Institution of Chartered Surveyors, also known as RICS. For those of you who aren't aware, we're a leading professional body working in the public interest to advance knowledge, uphold standards, and inspire current and future professionals. Our members help to create and protect the built and natural environments that are sustainable, resilient, and inclusive for all. We work inclusively with our members, supporting them in their practice and building valuable connections. With a heritage spanning over 150 years, we set qualifications and independently regulate our 110,000 chartered members across more than 140 countries globally, guiding decision makers with trusted data and insights to help shape public policy and deliver positive societal change. As part of my role here at RICS, I manage the RICS Tech Partner Program, which is a collaborative platform for innovative data and technology that produces thought leadership content and market insights for the profession. By partnering with tech firms working across the entire property lifecycle, we help our members to understand and adopt solutions that bring value to their professional activities. And in doing so, we aim to ultimately bridge this gap between the surveying profession and tech innovators, ensuring that the adoption of emerging technologies enhances the value we bring to the built and natural environments. Given the broad range of asset types and pathways that we cover at RICS, the topic of digital twins is very important. Digital twins can be applied in various ways, helping our members across different sectors and asset types, whether that's urban planning, real estate management, all the way to infrastructure and sustainability initiatives. Today, we've got a fantastic panel lined up to discuss the various facets of digital twins, their real world applications, and how they're transforming industries. We'll explore some of the challenges to the adoption and the skills needed to leverage it effectively in the future. So, without further ado, let's introduce our panelists. So, Michael, I'll start with you.
Thank you. Hello, everybody. My name is Michael Grant. I'm the COO and co-founder of Metrikus. We are a SaaS platform for the built environment. A building is a building to us. We have everything from large commercial real estate to warehousing and industrial to retail. We aggregate building data and then we normalize that building data and bring it into the platform and then push it out through our API so that other people can use it. And the topic of today is digital twins. We push it into other systems like ServiceNow WSD and their sustainability platforms, but also into some other mapping and digital twin platforms for the built environment. So customers globally, again, a building is a building and industry is an industry to us. As the other two panelists will probably talk about as well, most buildings are inefficient, but we help to make buildings more efficient. Most of our projects are retrofit, but we are doing more and more new buildings as well, which something Tiffany will talk about, I'm sure, and how we go from where Tiffany finishes and we step in to continue the journey, because at the moment, and we all know historically, it's very start and stop with the built environment. So making it continuous is really important. And we help bring all of that data together and give it to the right people for them to use. Not everyone needs the same information, but making it standardized and normalized is one of the key USPs that we provide.
Thanks, Michael. Rick?
Hello, everyone. My name is Rick Rolston. I'm the president and co-founder of BuiltSpace Technologies based in Vancouver, Canada. Like Michael, our emphasis is on the built environment as a SaaS platform to manage whole lifecycle asset management and service management, including construction through operations and maintenance and retrofit, so the full life cycle. And like Michael, we work across numerous segments from infrastructure, utilities, even industrial, through commercial. So if it's not a single family home, we will probably be involved.
Great. And last but not least, Tiffany.
Hello, everyone. I'm Tiffany Hosey, CEO and founder of CTBIM. It is a SaaS platform, and we're a data technology company for complex construction projects. And we're really industry agnostic, so it doesn't matter if it's a vertical or horizontal project. Basically, what we provide is the ability to capture real-time data as structures are being built. That allows for project owners and construction managers to have real insights into all the activities in the field, from when inventory is received to when inventory, when items are built, schedule progress, and budget progress. So we aggregate all that data in real time and pour out a ton of analytics that anyone can read from any location worldwide, and understand the schedule and budget health of their projects, and also to help mitigate a lot of the risk inherent to field activities. So I'm looking forward to the discussion today. And Michael's right, what we do really does feed right into what they do post-construction in terms of digital twin data and being able to help buildings, structures run more efficiently.
Thanks, Tiffany, and to all of our panelists there for their introductions. So let's start by getting an understanding of what digital twin technology is and how it applies specifically to the construction and building industries. For me, the concept of digital twin is a digital replica of a physical asset, systems, or processes, often updated in real time through data collected via sensors and other technologies. In construction, digital twins can provide an in-depth perspective of every phase of the building life cycle, from design and construction through to the ongoing operations and maintenance. The technology has grown a lot over the years, and today, especially with advances in Internet of Things, AI, and data analytics, we can use digital twins not only for monitoring, but also for predicting and optimizing asset performance. So as we start this discussion, I'm curious to hear from each of you on how this concept has evolved and what it means for your areas of expertise. So Michael, if it's okay with you, let's start by really breaking down what we mean by a digital twin. So how would you define a digital twin, specifically in the context of energy efficiency and sustainability for retrofit projects, for example?
Yeah, so I think digital twin means different things to different people, and we discussed this previously between us, right? But if you're the person looking after sustainability and energy and understanding the utilization of your space or your building or multiple buildings, a digital twin can be as simple as having the energy data from your building available in a platform broken down by floor or distribution board, and then going all the way down to a building level. And then having that data available, whether it's in a 3D BIM model, that's something that Tiffany would produce as part of her process, or whether it's a simple floor plan, so you can 2D floor plan where you can see the layout. I think the super cool, all singing, all dancing 3D model with everything in it is for the built environment and seeing pipework and layouts, but the person who's in charge of understanding building efficiency and building energy and HVAC, they generally are used to looking at 2D models. So it more about the data in this aspect than it is of a 3D model. But the 3D model helps when you're looking at a building and trying to understand which part of the building you're actually talking about as well. So the data, how accurate that data is, where that data is coming from. So is it coming from a BMS? Is it coming from a sensor that's a CT clamp? Is it coming from a digital meter or a smart meter? Or is it coming from literally, bills that are being put in, into a computer, into a platform, and then you can retrieve the data, very, very old school. But all of that data can still be put into a platform and used and utilized by people. So in its simplest format, digital data available to the person who needs it, and with the timescales that they need it, but also wrapped up against some other data, because a lot of buildings, they run the HVAC from 7 in the morning to 7 at night, but they don't look at how many people are in the building or how many people are on each floor. So those two data sets really help you correlate how the building's being used and how you're running your HVAC and how you can save energy. Now, they're both digital pieces of information, and you put them into a digital platform, whether it's your laptop or a machine model. But those data sets help you understand. So it can be as simple as the right data in the right place in the right format that you need it, or it can be a lot of people are visual and they need to physically see where it is to help them understand what's happening in the building. So you've got one end of the scale to the other, really.
Oh, thanks. You explained that really well. Rick, I'll move across to you. You mentioned how you cover the entire property life cycle. So given that you cover all aspects of that, how would you define digital twins?
I think, like Michael, the idea that a digital twin is a 3D model is very limiting. because whole life cycle means existing buildings, infrastructure, underground facilities that just simply isn't digitized within 3D. Very, very few of the buildings actually have BIM or 3D models. So, if we think of, I'll call it an Uber scale digital twin, and our focus is on asset management, then we have to start thinking about putting the user into the real world, supported by the digital twin on their mobile device. So, being able to identify and locate, wayfind to assets, in a building or out in a green field somewhere. All of that is driven by digital twin technology. Uber itself is an example of a digital twin for point-to-point services delivery. So, what we're doing in the built environment is really very similar in many ways, but in our case, it's point of service delivery of those services, and it's all underlaid by digital twins that let us navigate to where we need to be, generally in a GIS, geolocated manner, in 2D, if you will, but with the data that is derived from systems like Michael's or from Tiffany's, at the point of service on a mobile device.
Thanks, Rick. And Tiffany, we've had some good definitions here from Michael and Rick, but taking a look at this from a construction perspective, how would you define digital twins, and how are they being used differently?
Well, the way that I describe it is fairly unique, and it's something that RICS recently had a paper written about, which is this idea of a production digital twin. And we're really the only company right now that does it, and it's not really focused so much on the 3D visual of a digital twin. It's really the data capture that is a mirror image of a structure being built in real time. So if you can imagine having a structure being built and a database that allows the construction crew to know exactly what widget goes in room 100. So say it's a door, the door type, material, manufacturer, all that information is in the database. Also the line item budget for each of the contractors and the schedule. So that allows for a capture in real time of all the activities that go into building a structure in tandem with what you can see physically and, out in the real world. So that production digital twin allows for all the information you need for mitigating or managing claims disputes, and understanding where you are in the schedule and impacts on productivity when there are issues that happen, maybe a new pandemic where people go down and you need to, protect the bottom line of your project. It allows for that kind of data to be captured and used in order to help predict what's needed to protect the bottom line of a project. So you realize that in this industry, we have about $2 trillion worth of waste globally realized from things like waste, fraud, and abuse. And a lot of it is because of the opacity of process. What a production digital twin does is allows for the removal of that opacity of process and gives the owners and empowers the owners and people overseeing projects to really have the data to be more proactive, to manage and to reduce incidences of mistakes and errors that otherwise could be avoided.
Thanks, Tiffany. And we've really touched on there the importance of data. So, Michael, I'll move back across to you. Maybe linking back to some of the points Tiffany said. What do you think are some of the key data points you focus on when creating a digital twin for existing buildings?
So for us, it depends on the customer. So where they want to start and where they want to end up. Every customer grows because everything Tiffany talks about is saving people money and time, and people suing each other in litigation into buildings, but we do the same thing. So our customers, depending on where they start, so customers who want to understand how their building's being used, and especially post-COVID, everyone's got too much real estate. So how is my space being used? How many people are coming in and out of my space? And then how is that space being run? So how are we letting people in? How many people are in during the day? The data then helps them understand, number one, how much real estate they need. So that's an easy. People in and out, people on each floor, people in the building. Everyone knows they've got too much real estate. So that's a number one. Number two, if you have restaurants and cafes and things, that same people count data can help inform how much food they should buy, how much, so you can reduce wastage there. When you're running the building, how you're running the HVAC, as I mentioned a bit earlier, how you can see when people come in. And a prime example of this is one of our big customers, and we have a public case study on this with Accenture, is their landlord was heating the building for hours before anyone came in and for hours after people left. So by using the data sets of indoor air quality and people count, we were able to help them go to their landlord and ask them to make changes. And they saved $30,000 on energy in the first 3 months. And now they shut down whole floors on a Thursday and a Friday, and they're saving about $5,000 a day. Now, that's not a lot of data that they're taking in, but it's really important data and really valuable data. So there's only 2 data sets there, but it's driving a lot of savings. So data is key, and everyone says data is the new oil, and it is, but like oil, unless you refine the data and you do something with it, you can't understand the data and drive value from it. So that's the most important part, because there's data everywhere. If you look at how much data Tiffany and Rick both put into their platforms, they refine it, but if it's not refined, then you can't use it. So that's the most important part, having it in a shape and a format that you can take advantage of and do something with. And the more people that can use that data in the building, the more valuable it is to everyone, because you don't have to buy multiple platforms and multiple data streams from multiple vendors. If you can get it all in one place, then that again drives the value of that data up and creates a faster ROI for the people that are using it.
Great, thanks. Rick, do you have any comments to add on that?
Yeah, I think there's many different data sets, and in our case, the data that we focus on is any data that is related to a business process, and whether that business process is pouring concrete or cleaning washrooms in existing buildings. There's a cost to that, and there's an efficiency available. Labor is the most expensive energy we have, and how can we operate that more efficiently using data, from Michael's systems, for example, on air quality or occupancy, defining when the washroom should maybe be cleaned again, and that kind of I'll call it service orchestration is where we all can find enormous gains in automation. And what I see today is the AI capabilities are very, very quickly helping to make that data more understandable and dynamic in nature, to be able to actually orchestrate people's actions on a minute-by-minute basis, as opposed to week by week, which is typical in a construction project today.
Thanks. And Tiffany, moving across to you, given that you implement your digital twins right at the beginning of this property lifecycle, could you elaborate on how digital twin technology can provide more of a holistic view of the building lifecycle, all the way from construction to ongoing operation?
Sure. So the way that we do it, since we're collecting data on when assets are being installed and then being put into service, we are well positioned. We have the data that allows a project owner, a building owner, post-construction to understand maintenance cycles, be able to predict when things are going to break down, and sort of be proactive in dealing with that. In terms of, if you think of a building as a living, breathing thing, that because nothing in a building or a structure stays static because things break, things need replacement and repair. The system takes in that data and always has the latest information. One of the big things in construction is if you give a structure over to someone else, and the as-built are supposed to be a representation of exactly what was built, and oftentimes it misses a lot of information. What our system does is, since we're capturing data in real time, and then as things are changing, updating it, the as-built records should always be really, really accurate. And so that allows for a more efficient running of a structure. You don't have to chase paper to figure out where the specs, manufacturer specification sheets for certain assets, so that you can understand, what parts need to be replaced and how to order it and things like that. Beyond just managing the facility, though, these issues come up. Things happen where maybe people get hurt because they didn't know that there was an electrical conduit behind a wall because the as-built didn't show it. We can avoid a lot of injury to people, and eliminate a lot of bad things that can happen because they don't have the most accurate information. So things like, if you're in the private sector and you're doing cost segregation studies and you need contemporaneous records to substantiate your claims for accelerated depreciation of assets, all that data is there because it's real-time data created. If you have claims disputes because let's say there's a flood, in a condominium, and there's a common wall where the flood is going down floors and affecting a bunch of different condominiums, but different owners. Insurance companies would be very, very interested in having the kind of data that helps them pinpoint the responsible parties for defects. So there's a whole host of benefits to having that kind of data that, again, is well organized, standardized, and accessible to different stakeholders throughout the life cycle of a project. And the last thing I'll say, and I didn't mention this, but let's say you're owner of a hotel group, right? And you're building structure A and structure B, the same resort in different locations. Well, if you use the system that's collecting data during construction for structure A, all of that information will help inform better estimating, budgeting, planning for building B, and on down the line. A and B will inform C, and take it from there.
Thanks, Tiffany, and then thanks to everyone on that topic. Now that we've got a good foundation, let's explore how digital twins are transforming building operations and helping increase efficiency. So, digital twin technology allows building managers to continuously monitor asset conditions, performance, and utilization. With real-time data feeds, managers can optimize everything from energy use to maintenance schedules, making it easier to proactively address issues and extend the asset lifespan. The technology is improving operational efficiency, and for large portfolios, it can lead to significant cost savings. So on this topic, Michael, I'll start off with you. Can you explain how digital twin models help track a building's operational performance over time, especially in terms of energy usage and maintenance?
Yeah, so when you're connecting to the building management system or building automation system, or HVAC, depending on what you've got, though everyone has a full BMS or BAS, but when you can connect to those systems and pull that data out and put it into a system and write rules against it. So fan speed, for example, if a fan coil unit, the fan speed is supposed to spin at 50 RPM, and you put a rule in that when there's an anomaly detection, that if it goes for 55 or 60 RPM for a second or two, you don't really care and you don't need to worry about it. But if it goes at that speed for 5 minutes or 10 minutes or more, then you need to be alerted, because as Tiffany said earlier, if you don't track some of this stuff, you don't know things are going to go wrong until it goes wrong. So if you've got the digital representation and you can pull that live data out and then you can write rules against it and you can do anomaly detection, then you're in a much better place. The fan coil unit will run more efficiently. The fan speed running at its normal speed will help you keep your energy costs down. Repairing it before it breaks, extends the life of that piece of equipment as well. So there's a lot of things when you get the data out and you put it somewhere else that you can use it with, it goes to the point of, if you had anomaly detection and you could see that it's spinning at 50 RPM, that's one thing, but then you have to do something with that. So where do you put that? You either put that into a digital twin platform or you put it in a workflow system. We've got a big partnership with ServiceNow. So if there's anomaly detection on a fan coil unit and there's an RPM problem, we will raise the ticket through ServiceNow. They can start a workflow that can create a job for an engineer, and then that engineer can go and do the work. Now, when they get that ticket, it has the building, the floor, the area, the unit, the serial number, and everything else about it. And we could have pulled that from a system like Tiffany's or RICS, so that when the engineer goes, they increase their first time fix rates because they can go with the parts they need. So all of that information and that data is critical, and we can pull it from different systems and put it into one place where it's needed. But the economies of scale on extending your equipment life are huge, right? Because they're maintained once a year or twice a year, whatever the regulations are in the country or the state that you're in. But if you can be proactive, everything's reactive because there was an anomaly detected. But if you can react to that sooner rather than later, you're extending the life and you're helping keep that building, help that building run more efficiently. Because when fan coil units and filters get blocked, then they use more energy, the filter gets blocked, so the fan speed has to, pump harder to get things through it. And then, all these different things happen. So it creates a sequence of events that if you can take action because sooner rather than later, there's a whole heap of savings to be made in that whole chain and that whole process.
Thanks. And Rick, moving across to you, given some of the points that Michael just said, as a building evolves, there's a need for more data. So how do you ensure that digital twins remain relevant and accurate throughout the whole entirety of a building's life cycle?
Well, I think the key thing there really is it has to be live. The digital twin. I would call it an operating digital twin as opposed to a production digital twin in a way, but all of those services that are happening, the air filter example, there are buildings with hundreds or thousands of air filters in them, and managing that reactively just isn't a solution. A good example, a hospital, the team today, probably 15 people, go around twice a day and manually read the pressure drop across the air filters and the air handling units on the big units and track that. We can take that data and trend that data and predict, when that filter set will be ready for replacement, even with manual data read twice a day. But to take that example and automate that, deliver that across hundreds or thousands of units is a game-changing solution. We also see opportunities to the people that use our application on their mobile devices are actually physically changing those air filters. So we know exactly when they were changed. We have them take a photograph of every air filter that's changed. And AI is now very capable to say, we could have left that filter for another 2 months. It's pretty clean. Maybe it's in a clean location, or the occupancy of that space is negligible, or the fan speed was way down over that period of time. Taking all of that data, and I think the true value of proactive maintenance comes when it's there's no longer a ticket, go change this, but a service plan to say, this group of a dozen filters with these filter sets should be changed this week, and optimize that, again, using AI, machine learning to orchestrate those kinds of services. And I think the other piece that we really forget about is, very large facilities have very large asset counts, very large spreadsheets of assets, and there's some poor soul sitting at a desk trying to figure out, whether the work's been completed or not, and automating that aspect of it with live asset management, relieves that person to go do something more efficient and effective.
Thanks, Rick. You and Michael there have touched on how digital twins can make building processes more efficient, but taking a step back and looking at construction, Tiffany, how would you say that this technology can aid in tackling production activities on construction sites, and how does this influence the timeline of a project?
So when you're able to have a system that allows for an objective capture of data on productivity, when assets are received on site, when assets are, when parts of the building are built or assets are installed, that allows for the person who's overseeing and managing the project to really understand the project health, where we are in the schedule, and gives the owners of projects an understanding of, am I going to be able to get my certificate of occupancy on time so that I can, have this grand opening, or are there things that are going to impede that? The other thing is, when you have a design build job, there usually is a lot of change orders. And when the contractors are claiming, writing their invoices or proposals for how much it's going to cost to do a change order, my experience from running a construction company is that we really use estimates on how much time we think it's going to take to install a window or door and how much it's going to cost. So by having data in the system to look to say, on average, how long did it take to do an installation, and then use that to compare against time claimed on change orders, you're very well positioned to better manage that process. And also, when you know exactly what materials have been received on site, you can actually use that information against what information is in change orders to say, well, you really don't need to order this particular part because there's a change order. You should have, based on the system, X number of these assets already on site. So let's take that off your change order. So things like that really does help manage the process of construction a lot more efficiently. And then when there are claims disputes and folks are, saying, I painted the wall perfectly. See, look at the picture. Then someone comes in behind you and causes damage, and there's a dispute about who's responsible for the repair. It really cuts down that process because you have contemporaneous records of completed build activities that a contractor can hold up and say, it was perfect when I put it in. So, that's a discussion to have with another contractor. Those kinds of things makes the process go a lot easier. And another thing that we do is, if you have, like, one of the things that happened when we were on site is there were biometrical locks on doors, and they had never been installed by our carpentry firm before. And so we had to fly someone from the East Coast, we're in Virginia, from the West Coast, we're in Virginia, to train them on how to do the installation. Let's say the training happened on January 1st, but the building wasn't ready to receive installation until that summer. So they're losing that knowledge of what was taught on how to do it. But we can take sort of the installation manual, create a 3D video of how to do an installation to refresh their memory, and they can follow each step one by one. And that allows for them to be able to do it correctly. And you have a record of it. So it's there not only during construction, but post-construction, when you're maintaining a structure and things break down and you have new, people retiring who are maintenance folks, and you have new people coming in, you can have that information to train them on how to properly do maintenance and repair of assets. So it really does have, like, that data can be used, like, from beginning to end on a project, and then post-construction to maintain a building.
Thanks, Tiffany. That leads us on very nicely to our next topic of data-driven decision making. So By collecting and analysing data from various sources, whether that's temperature sensors, occupancy levels, and energy meters, digital twins offer valuable insights that help organisations make informed, proactive decisions. The vast amounts of data not only allows for real-time tracking of progress, but also helps to identify areas where resources are best allocated and predict potential issues before they become problems, like Michael and Rick have mentioned. In essence, this technology improves building performance and allows managers to respond quickly to changing needs, whether it's optimizing energy use, improving maintenance, or ensuring that systems are running as effectively as possible. So I'm interested to hear your perspectives on how data influence decision making in your areas and how it's driving operational improvements. So, Michael, I'll start off with you. What types of building performance data are most critical to track using digital twin technology for effective decision making? And I know we touched on the key data required, but what's most important to track here, and what sustainability measures do you find that you're tracking?
If I stick with commercial real estate rather than jumping into any others for now, but the commercial real estate side, people want to, and this is where AI and machine learning come in, and we ask every customer to tick a box when they want to work with us and say, we will let you have all of our data from all of our buildings that we anonymize and we put into AI and machine learning, because one customer may only have one building of 10 floors of 20,000 square feet in New York, but we have lots of customers with buildings in New York. And if they want to understand how their building or how their floors are performing against someone else, you need lots of data sets to compare that. So, and we don't have a single customer that hasn't said, yes, please take our data, make it anonymous, because they're going to benefit from it as well, because then you can do league tables and understand how other buildings are performing. So taking all of the data that you have in a building, putting it into AI and machine learning, the biggest output that we are being asked for is predictive occupancy and predictive energy use. And both of those then come together to help make sustainability goals a reality by understanding historic usage, not just of your own customer, but of all the other buildings in your area. And then we also take in data that's not coming from the building. So we'll take in transport data, weather data, what's happening in the city data, if there are events and other things on, because all these things have an effect on your building's usage and how many people are going to come in and out of those buildings during the day. So for us, it's getting as much data from in the building and outside the building to really help make them sustainable and help improve on energy. But, the collective set of data for lots of buildings rather than, one customer, we've got one customer with 600 buildings. We haven't done all of them yet, but they don't have 600 buildings in one location. They're all over the world. So when you've put lots of buildings, say take New York, there's local law 97, when it finally kicks in, there's 25,000 buildings that need to comply with that. There's more than that building wise in New York itself. But imagine having all of that data and being able to share it with others so that they know how efficient their building is or not compared to others of exactly the same shape or size. The more we have of that data, the more we share it with others to use it, the more energy efficient we can make all buildings globally. So that's for us, the openness of data and bringing it into one place so everyone can use it. That's core for us, and it's what we ask everyone to do. But that's really how you'll start to make proper changes in energy usage and sustainability, and then the operations of those spaces.
Thanks. And leading on this topic, Rick, how would you say that you ensure the quality and consistency of data in large digital twin applications, especially when, like Michael just mentioned, when managing hundreds and thousands of assets?
I think that the trick there really is standardized processes, and for us that means, I'll call them smart maintenance or smart operations processes that are shared across the trades and the often different stakeholders that are required to either provide or consume that data. And in a building context, very often we have in-house staff, we have third-party vendors coming into buildings, electricians, plumbers, and so forth, and to be able to capture data across those trades and so forth. The secret really is creating standardized processes that are available to those stakeholders on their mobile devices with the data, previously service records and IoT type data, energy data if required, that can help them better do their job more efficiently. And then we need to measure that. So the data that we're measuring tends to be what actually changed. And it's interesting. We have in our own building, our own office building, where we're a tenant. We've been involved with them for many years, and the services during COVID were tended to be things like cleaning, disinfection, but then air quality and so forth. And in that example, the landlord installed the VFDs on all of the air handling units on each floor. So they put in, I think, 15 different VFDs. I discovered it when I was in the mechanical room and went, oh, that's interesting. But the most interesting piece of it was there was no indication that anything but the VFD was installed, and there was no programming to say it shall be reduce the fan speed at this point in time or anything of that nature. It was if you put the equipment in, that's enough. So there's I think a vast difference between sort of measuring energy and measuring anomalies and measuring what could be in terms of energy efficiency improvements and return on investment for those types of investments.
Thanks, Rick. And moving on to construction, Tiffany, how would you say that real-time data inputs influence the decision-making process during construction, and how does it get incorporated into a digital twin?
Again, our digital twins are sort of the production digital twin. It literally is, that's what it is. We're collecting data that is a mirror image of the physical structure going up. So the data is very useful for productivity analysis, being able to, because we have an AI tool as well. So we'll be able, what it does is able to allow project stakeholders to understand schedule impacts of any changes, anything happening in the field in real time, budget impacts. It also helps with risk reduction from being able to identify the high performing contractors and low performing contractors for current and future projects. Also, the reason why the data is valuable and reliable is because it's collected in an objective way, and it's 100% auditable. And I think everybody's familiar with the idea of was it garbage in, garbage out, GIGO or something like that, GIGO, whatever. So to the extent that we eliminate that as a factor, the reliability of the data reduces risk. It has an unintended consequence of increasing safety on projects because people are not having to. There was a study done that said a lot of people on construction sites in QC don't report things that are happening that are defective or shouldn't happen the way, because they're afraid of being reported, being the person that reports and having a negative impact on that, like losing your job for being a whistleblower. So if you're having the ability to capture that real-time data and as it's happening, you don't really need to rely on someone telling on someone, because you can see, oh, the bolt on the airplane wasn't put in, and so the door won't fall off because we captured a photograph in real time and someone caught it and was able to take care of it. So there are a lot of really great outcomes that come from being able to have the information that allows for proactive decision making maybe it's reactive the first couple of times, but after the first couple of times, we're able to be more proactive and say we can anticipate these things happening and then take action before they do.
Yeah, it's all about having one single source of truth. But just one quick follow-up question for you there, Tiffany. Do you think there's ever a danger in collecting too much data?
There's no such thing. I mean, it really is, and it depends on your perspective, and that's a really, and I said that tongue in cheek, but I'm actually quite serious, because as a lawyer, actually did a great deal of research to understand why the industry, because being able to collect data is not, so innovative and so, oh my gosh, this is crazy. It's really common sense, right? But why is the industry so slow to embrace the ability to collect the kind of data that reveals what's really happening in real time on construction sites? And there's a doctrine in the law in the US called latent and patent defects, right? And so a latent defect is basically you can absolve yourself. Is plausible deniability. I can't be held responsible for bad outcomes, for injuries to people, if I had no reason to know that there was this latent defect in place. Well, if you're collecting the real-time data, it really does diminish the ability to claim plausible deniability. And I think in some ways, there's a resistance to a paradigm shift that really diminishes the ability to claim, plausible deniability. But I think because technology is so prevalent and it's moving at the speed of light, I think a lot of stakeholders are going to have to understand that there's great value in being able to pinpoint issues as they arrive, and then really diminish the instances of latent defects as a concept as a whole.
Sorry, I would jump in that there is an ROI on data, and yes, there, in my view, there is data that is just simply doesn't make the cut, and for me, I look at that and say, okay, is it a part of a business process? And to Tiffany's point, risk management is a business process, but and it's sometimes hard to determine what the ROI is on preventing a lawsuit down the line. But at the same time, these decisions as to what data we collect and what we don't collect in a building or in an environment are financially driven at the end of the day. And one of the problems in the early days of sort of the IoT space was, we have essentially doubled the number of assets that we're managing if we have another asset managing the data collection for the first asset, and the life expectancy and the flatline sensors and all of that tended to add to the costs of doing very complex sensor automation projects. So to me, there is a cost benefit that we have to weigh, and it may not make sense to capture, what was the temperature every 15 minutes in an office building, and store that forever, because who cares?
Yeah, good point. Which again ties us nicely onto our next topic, and it can't be an honest discussion without looking at some of the challenges. So with any new technology, especially one as complex as digital twins, there are bound to be challenges to adoption. Integrating digital twins into established workflows requires both technical and organizational adjustments. Key concerns include data privacy, ROI, as Rick just mentioned, initial investment costs, and the complexity of scaling the technology across multiple assets or projects. There's also a need to ensure that the data is accurate and up to date to maintain the integrity of the digital twin over time. And addressing these issues is essential for organizations looking to leverage the full potential of this technology. Michael, going back to you, what would you say are some of the key barriers to adopting digital twin technology for existing buildings, and how can they be overcome?
Again, I think it comes back to who you're talking to in buildings. So facilities managers and facilities teams they probably all hate me for saying this, but a lot of them like to wear their underpants on the outside, right, and be Superman. When something breaks, don't worry, boss, I'll fix it. But and that is, when you and we were working with a law firm years ago, and we met one of the lawyers at a show. He was one of the partners, how they could make their buildings more efficient from an energy and sustainability standpoint. He didn't think about the productivity from air quality until we explained it to him. But when we present to him and his team, and we talked about how if we can connect to the building management system and pull all the data out, how efficient we could make the building and how efficient we could make their engineers, at the end of the meeting, they all said thanks. And then the facilities guy called us back for some follow-up questions and said, look, guys, this is great, but I think you're going to do me and my team out of a job, so I'm not going to recommend it. Now, that's the wrong attitude, but he was trying to protect his job and his team. But, they could be repurposed to do something more efficient and more valuable in the building, as Rick and Tiffany have both said earlier. So there is resistance from people not wanting to change and wanting to make sure they keep their jobs. And then maybe that's all for the wrong reasons. The other part is the technology side. IT are slightly worried about IoT devices, and are they as secure as IT and trusted devices? Having them pen tested, running through, getting the rigor around each device, and can it tell you who's sitting at a desk or who's coming in? Can you spot people? All those sorts of things. Getting that out the way and dealing with those up front is the best way to try and ease the process. But as Rick said, when you're adding one device to manage another asset, that's already there that you could get the data from, before you know it, you've got lots of devices in a building, and IT will call them rogue devices, so because they're untrusted. So there is a process to go through for that. And if the customer really wants to do it, and they'll really go through the process, and IT will spend the time and the money, it's generally time to go through those processes, there is value out the other side. But a lot of people don't want change. I mean, real estate, I came into this industry like Tiffany. I was in a different industry before. I used to build data centers and networks and had a previous software company in unified comms. Coming into the workplace / smart building space, I was surprised how slow things move, right? So people don't like change because they're so used to the ways where they make money. They know what their margin is, and they know how long the process is going to take, and they want to get to the best part possible. From Tiffany's perspective, she mentioned it earlier, I want to do as much or as little as possible to get my PC so I can go on to my next job and then go and do something else. So getting people to move with change and move with technology and move with data and requirements and standards and everything else that's going on, that's one of the hard things I think we see. But I think it's changing. I think it's taken a long time to change, but I think sustainability, energy savings, and trying to help the planet as much as possible and reduce costs, especially with the economic climate that we're in, that's what helps reduce the barriers. But there's always a barrier somewhere, right? You've always got to try and push those down in the nicest way possible to keep things moving.
Thanks. And continuing on this topic of resistance to change, Rick, I'll ask you, how do you say that we overcome this initial resistance to adopting digital twin technology and other types of tech within organizations? How do you suggest we tackle that?
Well, I think the idea of energy efficiency has been a horse that's been beat for a long time, and the realization that decarbonization is a much stronger driver than finding energy efficiency per se. It's not just, okay, we're going to make operational changes to reduce energy consumption. It's now we need to physically change these buildings to make them more, reduce their scope 1, 2, or 3 emissions over time. And so that is, I think, one of the big drivers that is pushing the adoption of digital twins, because the digital twin is the holistic model, going from reactive Superman maintenance teams to a decarbonization model that's driven by digital twins. Like, that's a massive leap in even concept. So obviously there's a lot of barriers to it, but there's also some drivers. And AI is another piece that I think is very quickly becoming a major driver, because unless we have a holistic digital twin with detailed data that allows us to make decisions, and energy is one piece of that decision, but what's behind the meter is another huge piece. Is it operated properly? Is there a VFD that's actually operating as it should? Are there the appropriate occupancy sensors and all of the things that contribute to an efficient, sustainable building? Like all of that stuff has to come together in one place, and everybody here has a piece of that puzzle, and there are many other people that are also pieces of the puzzle that we haven't addressed with, and as Michael says, the people are the problem in terms of overcoming change in some cases, but there's I think solutions to it.
Thanks. And going back to this on a construction perspective, Tiffany, what would you say are some of the common misconceptions about digital twin technology, specifically the ones that hinder its adoption in construction projects?
A lot of the feedback I get when they understand the amount of data collected is, oh my gosh, I have to hire someone else and add to my budget to manage the data. And that's not the case. It's, I've actually had people come back to me apologizing for giving me a hard time when they realized that we were being used in a project, and saying, sorry, I was such a jerk. It actually helped me a lot more than I thought it would. So it's in terms of collecting the data during construction, it's truly a paradigm shift, and not having the luxury of not being fully transparent with your activities. It's something that is challenging, and it's different. And so for example, when subcontractors are starting to get paid closer to 100% for the work completed for a given pay period, versus having some of their pay apps cut because of these, interesting observations by the people responsible for approving their pay applications, saying, I don't see 15%, I'm going to only pay you 12. And you ask for real concrete information about why, what's the 3% delta that you're cutting, and they can't show it. The system shows that you're 15% complete. Here's the data. And then the contractors are happy because they're getting paid for that. So there are lots of things that the system does and AI does that allows for decision making and insights to be provided without, the labor of humans. And that's sort of very disarming when you experience it, because you hear a lot of data being collected, you think it's going to require a lot from your end, but it really doesn't. So it's a paradigm shift. It's an education process, and this is not a speedboat, but a locomotive, but a big ship that we're trying to push through these waters. And I think in time, people will come around.
Yeah, and I agree. We work on construction sites as well, and one customer, for example, has now done 2,500 different construction sites and put in hundreds of thousands of sensors, meter points, mostly for energy, water consumption, revenue grade stuff. And one of the things that we've found from that data is that their on-site efficiency has improved over the last 2 years by about 43%. And what that means is, counting the number of meter points that they install and commission every day, and we have very detailed records of what those points are and what the level of work was on it. So same team, 43% improvement. that gets them off of the construction site 43% faster, and allows the next trade to come in and do their work. So the idea that data is an extra cost to the general contractor, I think, is one of the biggest misconceptions that automation saves time and money, not increases costs. And so the industry has to adopt that. And our work is working with some of the major government labs to document how those savings are happening on those construction sites.
Thanks, Rick. We don't really have that much time to go through our final section. I'm throwing it all at you a bit on the spot here, but Michael, what would you say you're most looking forward to, or in the next 5 to 10 years? Say what do you see what do you see for the future of digital twins? What are you most excited about?
I think
where do you see it progressing?
Yeah, I think it's making buildings more and more efficient as much as humanly possible. As Rick said, it's not just about saving energy, but it's about how you reduce your carbon footprint and your carbon output and things like that. So that's not just about energy, it's about the whole process. So, speeding things up from where Tiffany starts and then where Rick picks up and then where we pick up. If you can change that. So most of the buildings that will be around for the next 50 years or 100 years are already being built, right? So you've got to change what we've already got. And if you can change what we've got, then the new ones that Tiffany and Rick are involved in, you can make those smarter and smarter. So I'm hoping the industry continues to change more and more to help make things more and more efficient, but giving the data to anyone who needs it to help others as well. So knowing how a building is being used in the built environment over the next 5 to 10 years and taking all of that data, we can then give it to the people who Tiffany works with to say, hey, look at this data from this building that was run for 10 years, and this is the HVAC unit, this is where it was, and this is how it operated, and this is how much energy it used, and this is how many people used it, and this is the way they used it. That can then inform how you design and build new buildings, and then that goes into Tiffany's process, which then helps make everything more efficient. And then you get this, it's not so much the circular economy, but it's a it's a circular motion that starts but never stops, but helps make things more and more efficient as time goes on. Because if we don't do that, we know the definition of insanity is doing the same thing over and over again and hoping it will get a different outcome. We really need to change. We need to change faster. And if we do that and we give everyone the data required, I think we're in a really good place. And with AI and machine learning adding to that value and adding to the predictive side of things that Rick also mentioned earlier, that there's really exciting things to come. I think we just got to keep pushing the boundaries and try and be more positive than negative in the space.
Yeah, I think Michael summed it up pretty well. But Rick, do you have any other comments? Any final thoughts?
I think it's inevitable that the built environment will be fully digital. It's the only way to reach the decarbonization and sustainability goals that are out in national programs everywhere. So the challenge of getting contractors and owners to adopt digital twin technology, it could be a full another hour segment, but I think it is inevitable, and the way in is through collaboration and us all working together. So leave it there.
Great. And finally, Tiffany, any final thoughts?
Maybe not in the next 5 to 10 years, but in the future, I hope to see a day when data is used to inform building, data is collected that will be able to inform how to build more resilient structures given the climate crisis. So if you have more earthquakes, more hurricanes, more tornadoes, more destructive weather events, what materials should be used, what designs should be used to make buildings more resilient, make structures more resilient through those events, and that we never see another apartment collapse in the middle of the night. That's just a thing of ancient ancient history. That's where I hope we see all of this data being put to use in its most impactful way in the future.
So to wrap up, it's evident that digital twin technology has the potential to transform the construction and building sectors, particularly in how we manage and optimize assets. The insights shared today highlight both the opportunities and challenges that come with implementing this technology. Thank you to our panelists for your valuable contributions, and thank you to everyone for being part of today's discussion. We look forward to seeing how digital twins will continue to evolve and impact the future of the built environment.